Welcome to the DIY Honda Galaz channel. Welcome to the troubleshooting guide for DTC P0533, which indicates a high voltage condition in the AC pressure sensor circuit for the Honda Accord model years 2017 through 2023. This error is crucial as it can negatively impact the air conditioning system's efficiency and performance. The AC pressure sensor is responsible for monitoring the refrigerant pressure within the system and relaying important data to the Powertrain Control Module, PCM. The PCM uses this information to adjust the AC system accordingly, ensuring it operates efficiently. When the DTC P0533 is triggered, it signifies that the voltage from the AC pressure sensor is exceeding the expected voltage threshold of 4.76 volts. In this guide, we will explore the detailed steps for troubleshooting this issue, starting from problem verification and moving to potential repairs. The DTC P0533 specifically relates to the AC pressure sensor, which plays a significant role in monitoring refrigerant pressure within the vehicle's air conditioning system. The AC pressure sensor is typically located near the compressor within the engine compartment, where it interfaces with the refrigerant lines. This sensor is equipped with a voltage output that communicates with the PCM to provide real-time pressure data. The PCM relies on accurate readings to adjust the AC compressor operation for optimal cooling performance. If the voltage signal from the AC pressure sensor is too high, it can indicate a malfunction, either within the sensor itself or in the wiring connecting the sensor to the PCM, potentially causing the AC system to operate inefficiently or not at all. Several potential causes may lead to the triggering of DTC P0533, including a faulty AC pressure sensor itself. If the sensor is malfunctioning, it might not provide an accurate voltage reading, leading to incorrect PCM adjustments. Poor electrical connections are another common issue, as loose or corroded terminals can prevent proper voltage transmission. Additionally, open wires in the circuit, specifically in the wiring connecting the sensor to the PCM, can cause voltage discrepancies. It is essential to meticulously check these components prior to proceeding with any sensor replacements to avoid unnecessary repairs. Proper diagnostics will help isolate the exact source of the problem, ensuring an effective resolution. When DTC P0533 is present, several symptoms may manifest, impacting the overall AC system performance. One common symptom is the air conditioning system failing to function altogether, which could lead to discomfort in the passenger cabin, especially during hot weather. High AC pressure readings may also be observed on diagnostics, indicating that the system is under stress or malfunctioning. Furthermore, the overall efficiency of the AC system may decrease, causing it to engage longer to achieve the desired cabin temperature. If left unresolved, these symptoms could lead to more significant issues within the AC system, potentially resulting in costly repairs. In the first troubleshooting step for DTC P0533, confirm the issue by starting the engine and allowing it to idle. This is crucial for creating the necessary conditions to assess the AC system's performance accurately. Next, you'll need to turn on the blower switch and then the AC switch. After these components are activated, use the Honda Diagnostic System, HDS, to check the voltage of the AC pressure sensor. The expected voltage threshold should be 4.76 volts or less. If the current conditions match the threshold, proceed to the next troubleshooting step. If they do not match and instead read higher, the problem may be intermittent, and it's advisable to inspect for poor connections or loose terminals at both the AC pressure sensor and the PCM. For the second troubleshooting step, first ensure that the vehicle is turned off to prevent any electrical hazards. Disconnect the AC pressure sensor by locating and removing the 3-pin connector. Using a jumper wire, connect terminals A and B of the AC pressure sensor connector to simulate proper function. Once this connection is made, turn the vehicle to the on mode without starting the engine. Again, utilize the HDS to check the voltage output from the AC pressure sensor. It should now read 4.76 volts or more. If the voltage aligns with this reading, it indicates that further investigation is required into the AC pressure sensor itself. If the voltage reading is outside the expected range, the AC pressure sensor should be replaced as it may be faulty. In the third troubleshooting step, turn off the vehicle again to ensure safety while handling electrical components. Proceed to remove the jumper wire from the AC pressure sensor connector, as you will now perform a voltage measurement at 2 specific test points. With the vehicle in the on mode and the AC pressure sensor disconnected, utilize a multimeter to measure the voltage between the 2 outlined test points. It's essential that this measurement reflects approximately 5.0 volts. If so, the wiring related to the AC pressure sensor appears to be functioning properly, and further investigation can proceed to the next steps. If the voltage deviates from this expected result, it indicates potential wiring issues needing further diagnostics. In the fourth troubleshooting step, begin by turning off the vehicle once more. To diagnose any open circuits, you will need to use the HDS to jump the SCS line, which will help simulate certain conditions. Wait for more than 1 minute after jumping the SCS line. Now disconnect the PCM connector A, which contains 50 pins. You will then check for continuity between the specified test points, the AC pressure sensor connector, and the corresponding pin on the PCM. The test should be performed while the vehicle remains off. Achieving continuity indicates that the PD sensor wire is intact. If you do not get continuity, it signifies an open circuit, and repairs should be made to rectify the wire between the PCM and the AC pressure sensor. Proceeding to the fifth step in this troubleshooting process, turn the vehicle off to ensure safety during diagnostics. Similar to the previous step, use the HDS to jump the SCS line and wait for over a minute. After this, disconnect the PCM connector E, which contains 80 pins, to access the relevant terminals. Similar to the continuity check in the prior step, you need to measure continuity between the AC pressure sensor connector and the corresponding pin on the PCM. This should also take place while the vehicle is off. If continuity is established, the SG6 wire is functioning properly, and additional investigation should be conducted regarding other potential issues. However, if the continuity check fails, this indicates an open circuit in the SG6 wire, requiring necessary repairs between the PCM and the AC pressure sensor. After the troubleshooting steps and any necessary repairs, it's crucial to perform a final verification to confirm that the issue has been resolved. Begin by ensuring that all repairs have been completed correctly and all connectors are secured. Once this is done, recheck the status of any existing DTCs using the HDS to ensure that DTC P0533 no longer appears. Following this, it's important to fully test the functionality of the AC system under normal operating conditions. Observe the system's performance, checking for cool air delivery and responsiveness. If the system operates as expected without generating further DTCs, this indicates successful resolution of the issue. Preventive maintenance is a pivotal aspect of ensuring that the AC system remains reliable and effective. Regular checks of the AC system will help detect any potential issues before they escalate into more significant problems. such as those signaled by DTC P0533, inspecting the wiring and connectors for wear, corrosion, or looseness can prevent intermittent signal issues and ensure strong electrical connections. Keeping all AC components clean, including the condenser and evaporator, will also enhance system efficiency and longevity. By implementing these preventive measures, owners can maintain optimal AC system performance and avoid inconvenient breakdowns. In conclusion, DTC P0533 indicates a high voltage condition in the AC pressure sensor circuit, which can severely affect the air conditioning system's operation in a Honda Accord from 2017 to 2023. Key components of focus during troubleshooting include the AC pressure sensor and the wiring that connects it to the PCM. A clear and structured approach to troubleshooting steps allows for the identification of faulty components and ensures an efficient repair process. By performing thorough diagnostics and implementing preventive maintenance, vehicle owners can experience consistent AC performance and avoid future issues related to DTC P0533. It is crucial to adhere to the detailed steps mentioned here for effective problem resolution. Please like and subscribe to the channel. See you next time.